Good morning, everybody. Welcome to class this morning. First of all, just let me say a couple things as we are getting started here. I want to say that I hope y'all had a nice break last week. You know, it's good to take a bit of a break every now and then. You know, especially, we've been working pretty hard this semester, getting things done, trying to learn some Java. So, being able to take a week off and kind of relax and, get our heads on straight for the last few weeks of the semester here is a good thing, right? Because, we're approaching the last few weeks of the semester. It's almost over. Just about, it's less than a month left, maybe about, 3.5 weeks or so now until the semester is over. But, now's not the time to slow down. We want to make sure that we are finishing strong. So keep your head up. Just push right on through. The end is in sight. We will be there soon. Also, as we get started today, I want to just thank you for watching. Thank you for taking the time to view this, for, trying to be involved in your learning. Whether you're watching live here with me or you're watching recorded later on, I always appreciate when you all, take the time to look at this stuff. And so this week we're talking about arrays. And so it's with arrays that we get a whole lot of power in terms of what we can do with our programming. And an array is essentially a new data structure. We're looking at a brand new data structure in Java. If you're familiar with other programming languages, you might be familiar with arrays. Because as we've kind of talked about before, it doesn't really matter what language you're programming in. The data structures are relatively the same. They might call them something different. They might have a different syntax, but in terms of the actual usage of the array in a program, it's basically the exact same. And so, if you've programmed in Python before, you might be familiar with lists, which is your Python version of an array. JavaScript has arrays. Everything has arrays, and they're all kind of treated similarly to the way we treat arrays in Java. But for those of you who haven't really had much programming before, haven't really examined anything before, we need to start with this data structure from the beginning. So we need to start examining the idea of what is an array. So what is an array? An array is a sequence of values. And the values in the array, we call them elements. So in terms of like a really highly technical definition, we can call an array a sequence of values, or a data structure that is a sequence of values. But we can take this and we can kind of break it down a little bit and make it a little more simpler and a little easier to understand. Because we can kind of put an array in the same frame of reference as to when we talked about variables earlier on in the semester. We said that a variable is essentially a container. So we talked about a variable in terms of a variable being a container. You can put something into a container. You can take something out of a container. And we can change the values that belong to that container as we go throughout our program. And so we have this singular container, and we can look at that as a variable. And that's a data structure. Now, when we look at an array, when we look at this sequence of values, what we're really looking at is sort of a sequence of these variable containers. So we can kind of think about our array, if it helps you kind of wrap your brain around what an array is. We can kind of think about an array as a container filled with containers. Or a box full of boxes. We can kind of, as we approach the idea of arrays, we can kind of face this sort of Russian nesting doll sort of situation where we can put arrays inside of arrays inside of arrays inside of arrays. If we're dealing with like 2D or 3D arrays. Now, one of the things to note here is that in Java especially, if you're used to arrays in other programming languages like Python, the Python list is heterogeneous. You can put any data type inside of a Python list. However, in a Java arrays are homogeneous. Just like everything else in Java, arrays are strictly typed. So if you want an array, or if you want to use an array, you have to type that array, and everything inside of that array has to have the same type. So if you have an integer array, all the values inside of your internal containers have to be integers. A double array, all the values have to be either doubles or whole numbers that it can interpolate into doubles. Strings, all strings, so on and so forth. You can make an array of any data type, just all the data elements, all the containers inside of that array have to have that same data type inside of it. So we're dealing with this sort of structure. Now, as we create an array in Java, we look at it in a very similar way to that of how we looked at variables. When we talked about variables, we talked about variables in terms of declaration and assignment. I need to declare my variable, and I need to assign values to it. And we said we could do that in separate statements, or we can do it all in one statement. And the same thing goes here. So to create an array, you have to declare a variable with the array type. And having an array type is just the same as you would with a variable type. Except after that type, you're going to put a pair of square brackets to denote that it is an array type. So if I'm creating an int array or an integer array, I'm going to declare it with my int data type with an empty pair of square brackets around it. Double. We left space for the U there, but we didn't write it in. With some empty brackets around it. String. With some brackets around it. Now, as we start the declaration phase, we can utilize these empty. But when we approach actually creating our actual array, when we're assigning it value, it's at that point where these things become a little more important. So when we're declaring an array, we can declare it with one of these data types plus, any kind of name. Right? Like we have some examples here on the next screen. So we have some array declaration examples here. Int count, double values. So we have our data type our square brackets and our counts, our values, or the name of our array. And so this essentially establishes that for lack of a better term, mother container, that container that we're going to put all of the other containers into, that parent container. Right? So by this statement, we've created this container. But then what we need to do from here is we need to be able to create all of the containers that are going to go within. And so in Java, as we look to assign values to an array, well, we're first going to use our array operators, and that's going to look a little something like this. So to create the array itself, you're going to have to use your new operator in the same way that we've done before to create ourselves an array object. So as we're assigning values here, we're going to say, oh, count equals new int, and in square brackets, 4. And so what this gives me is it gives me those internal containers. Right? So during the declaration process, I create counts. And so that establishes my container, that parent container. And then during this assignment process, we're saying new int 4 inside of the square brackets. And in that case, there, that number inside of the square brackets becomes really important, because this is what we're using to create all those subcontainers. So in this parent container, I'm establishing 4 subcontainers. So in this one counts array, I can put 4 values, because that's the way we've established it from this assignment. And so now I can go through each of these and I can put data into each of these interior containers. In the other example here, we have something that's very similar, except we're using a variable instead of an integer there to create my interior containers. So I can set that variable based on something else, based on user input, based on whatever. And so in this case here, the number of interior containers that we can have inside of our array is flexible. It's dynamic, because it's going to be based on that. It's going to be based on the value of that variable. Now, it is important to note that in order to be able to create this array here, we have to have our size variable with a value in it by the time we get to that point in our code where we're creating this new double variable. So again, essentially what we're doing here is we're making an object, and that object is making a copy of this variable in memory and giving us the ability to put these sub-containers in here so that we can create the data structure. So again, the first assignment makes count refer to an array, so that's our second bullet here is just explaining what we've already talked about there. The first assignment makes counts refer to an array of 4 integers. It makes those 4 subcontainers, and each of those subcontainers are integer. We can essentially think about them as integer variables. And the second one here is dependent on whatever the value inside of our size variable is at this point. Now, you can use an array, or you can use any integer expression for the size of an array as long as the value is non-negative, right? Like it has to be in the positive space. So we can have an empty array, which would be 0, or we can have as many as we want. from 1 to positive infinity. We can't have negative data inside of an array, right? We can't have a negative number of containers. That's sort of breaking the laws of physics, right? So we can have an array that has a size of 0 all the way up to positive infinity, but nothing negative. There is a negative size, array size exception that will be thrown if you try to use a negative number. So we want to make sure that we're not doing that. So let's go ahead and switch over to a REPL now, just so we can practice making an array. Let's see here. I always have too many windows open, so I have to find my REPL window in the list. There we are. And so let's create an array in 2 different ways. Let's create a way in the way that I showed you there. And then let's create an array in another more standard way so that we can see them function. And then we'll kind of look at another thing that's going to allow us to kind of help out with our arrays. So for this example here, I'm just going to stay inside of our main method. And I'm going to create 2 different arrays here. Let's go ahead and get rid of this system.out.println. And let's create some arrays. So I can create one in the way that we kind of learned from the slides there. So something like int square brackets. We'll call this one first set. And we'll set that equal to, or we're just declaring it now, right? We're just declaring it. Int first set. And then we could also say first set equals new int 4. And so this has created and utilized an array data structure in the way that we just looked at it. Now we can also do this declaration and assignment all together in one statement, the way that we were kind of working with a variable. So if I wanted to take this, cut it out here, add it here, and then remove this first set, that is also going to be valid, right? Just like working with a variable. And so what this has done is it's established myself a new array object that has 4 subcontainers in it that are awaiting integers. So we can actually kind of see one of the interesting things that we can do is use what we call an enhanced for loop, or a for each loop, to traverse an array to see everything that's inside of it. So I can write for int item in, or in this case it is colon. We read colon as in first set. So what we've done here is we've established a new variable, and we've given it a name of item, and we're looking for each element in first set. So essentially what it's going to do is it's going to traverse my array and get everything out of my array, just one item at a time. So if I system.out.println item, what it should do is it should go through the array, pull out every item, and print it. So in an array where we've just established this new array object here, using our new operator, let's see what is currently in this array that we've established. We'll run. We'll give it a minute. Seems like REPL wants to be slow this morning. Let's refresh this. Most of the time, using an online IDE is great. In times like these, not so good. So now let's run it. See if it'll... There we go. And so it establishes these containers, and it goes ahead and puts a 0 in each of these containers. Because we could think about this in a similar way to how we think about the stubs that we've been doing in the past. Right, if we have a stub for one of our value methods, we're going to put a temporary return value at the end that will later change with the real return value. So that's essentially what's happening here as we've created this integer array. We've created this integer array, and Java has put a little temporary value in each of my subcontainers that are inside my main container. Now, one of the important things to note here is that now that we have this set as a 4-container array, that's all you can have. No more, no less. Now we can change the values that are in this array, but in Java, we're kind of stuck with what we have here. So another way that we can write an array in Java is to just write the array with the data value as part of the, as the assignment. We're going to write the array with the data values already in place. So I'm going to create a new integer array, call this second set, and set it equal to. Now this is one of the things that's kind of a little bit confusing, because for most things with arrays, we use square brackets, but when we're actually defining values for arrays, we're going to use our curly braces. And we'll separate each item in our array with a comma. So we'll give it like a few values here. 2, 4, 6, 8. And now we have second set. And so if we want to iterate through these to print them out to show you the values here, we can, for item in second set, print out item, and we can watch it print out 2, 4, 6, 8. Very good. And so essentially what this is doing here is it's doing more or less the exact same thing as our new method here. The only real difference that we would kind of take in here would be whether we have these values already or where we're getting them, or whether we're getting them from another source. For example, if I want to go ahead and set my values, I could set them this way. If there were values that I wanted to use in multiple calculations or whatever. But if I were going to take different values from my user, what I might do is I might create it this way. And then let my user enter the value in. So for example, what I might want to do here is let's import our scanner. Import java.util.scanner. let's create a scanner object at the class level. So that would be public final scanner in equals new scanner system.in. We'll add an object to our main method, so that would be main obj equals new main. So we can access that scanner at our object or at our class level. And then inside of this enhanced for loop, we'll change that back to our first set. So what we'll do here is we'll system.out.print enter a number. We will take item and set it equal to obj.in.next int. And then once that's done, because we want to get all the values first, we'll do this enhanced for loop again. We can use the same variable name there, because remember, as we've talked about before, any variable that's inside of a for loop is scoped to that for loop. With something like that. So now what we should be doing here is we should be able to have this array created. Then for each 0 that's already in our array, it'll go through this loop where it'll ask our user to enter a number. It'll set that item to the number our user enters. And then once we have all the numbers entered, we will echo them back out to the command line. So let's give this a try, shall we? Enter a number. Let's enter just a random number of 45, 12, 28, 17. So now we've gone through here. For each of those containers, we got a prompt to enter a number. We've entered a number. It's taken that number, put it in those containers, because we set that item equal to the integer. So what we should expect to see now is all of these items echoed back out to us. Oh, but there's zeros. So that's an interesting thing. Why didn't that work? Well, let's try changing this to second set and see what this does. Because you might have thought that would have worked, right? Like that seems like it would have made sense to say that that would work. But why didn't it work? Well, let's try it with our array declared in our other method. It's going to give us the same thing, right? It's going to tell us to enter a number. We'll just enter some numbers. And it's still 2, 4, 6, 8. So we're on the right path, but we're doing something a little wrong here. So let's talk about how we access these different numbers inside of our arrays so we can understand why this isn't working a little better. So in order to do that, let's flop back over to our PowerPoint. and look at how we access elements. Now, when we want to access a specific element within an array, what we need to do is reference it by its array location, which is the reason why our for each loop there isn't quite working. We're not accessing it by its location, we're just doing something for each of the data values that are already in the array. So what it's essentially doing is saying, well, it's counting that array and giving you one thing for each of those array elements. And so we call this index location. When we access elements, we want to access them by index location. And when we start counting index locations in code, we start counting them at 0. So let's have a look at this array indexing example here. So we have this counts container, right? You can think about this as, we created this counts array, and then we initialized it with these 4 integers in it. So we've created these 4 containers in it. And these 4 containers have an index location. And this index location allows us to reference the specific data that's inside of that container. So we can kind of think of it like an address. Like, this is the address where this data lives. And so if we want to specifically target this data element, we want to refer to that as counts, and in square brackets, the index location of 2. And so utilizing that kind of notation is what's going to allow us to actually get into this container and see what's going on in there. Here are some more examples of that, right? So we have this, we could say counts 0 equals 7, counts 1 equals counts 0 times 2. So we can access these elements specifically. Counts 2 plus plus, we're incrementing counts in the index location of 2 by 1. Counts 3 minus equals 60, we're decrementing by 60. For counts in the index location 3. So what would we have to do with our previous example to use this access information to actually make it work the way that it's supposed to work? Well, we can still do this, right? This one can stay the same, because it's just printing out what's in there. This one needs to change. And for this one, I'm just going to write a regular for loop. For int I equals 0, I is less than 4, because that's the length of our array, I plus plus. And instead of assigning it to I, or instead of assigning it to item, we're going to assign it to the set that we're using, which in this case is going to be second set. Second set with the index location of I. So the first time through this loop, it's going to address the item in index location 0. And so if we look at our second set array here, that's 0, 1, 2, 3, right? So the first time through the loop, I is going to equal 0, so that's the index location that we have set here. So the first time through the loop, it's going to be addressing second set 0, which is going to be that 2. It's going to add 1 and make the index location 1, so it'll be addressing the 4. And the next time the 6, and the next time the 8. So if we set up our for loop like this, we can use this to change our data values. So let's give that a try instead. We'll say 12, 65, 87, 92. And now our data values are 12, 65, 87, and 92. So I kind of wanted to show you that situation with the enhanced for loop, with the for in loop, especially because if you've used Python before, you know, Python actually works when you do the enhanced for loop with the reassigning values inside of an array. In Java, it doesn't, because it's essentially creating an object, another copy of the existing thing in the array. So when you try to print it out afterwards, it doesn't really assign a new value to anything. It's just a copy. That's just sort of lost in the ether. So if we want to address these, we can iterate through our loop this way, or we can address them individually. Like, you know, we have our first set integers here. So I could address first set 0 and change the first number in that. First set 1. And we could say that is first set 0 times 2, whatever we want to do. So that'll take whatever number we put in this variable here and add that in there. Then we can go ahead and make a little, you know, double up here, you know, for whatever we want to do, right? First set 2. We can do that kind of like what we saw in our slides there. We can just make that, we can increment that and have it E++. That'll work. And maybe first set 3. Let's decrement that. Minus, minus. And so in this instance, we've added values to each of these array elements in our first set array manually. And in this instance here, which is a more useful instance most of the time, because like if you're going to do this, you may as well just do what we've done here on line 11 and go ahead and set everything that way. Although you can also do this the long way, where you like get data values and add them, you know, as variables here, and then it puts them into there and does all that kind of stuff. But we can create a for loop now. Let's just copy this for loop, this enhanced for loop, so we can print out all of the items that are currently in our first set. So we can do one for first set and one for second set. So the first thing in our flow of execution that it's going to ask us here to do is this for loop. So we'll have to assign some values. And then the first 4 numbers here are what we assigned manually to our first set. And our second 4 are what we assigned dynamically via our second set. Now, one of the interesting things that we can do here as well is we can use these individual index locations after we've assigned them to do calculations, to do whatever we need to do. Right? We can use these data values at these different index locations like variables. That's why we like to say that this is essentially a container filled with containers. Because not only can I take these interior containers and put data values into them and take data values out of them, but I could also use them as variables at different points in my program. So it does indeed operate, this data structure does indeed operate in that sort of manner, which is pretty interesting. Right, so let's just look at a few more things really quickly. Because I want to have this slide here as a text element for looping and indexing. Because this is exactly what we did to change the data values in our slide. We can also just print them out that way if we want to. Because essentially what we're doing there is we're just accessing the data values at each interior container, at each index location inside of our array, which is exactly what we want. So let's talk a little bit more about arrays. In fact, I've got another slide deck here for us called More About Arrays. And so what we've done here is we've seen how to, we've already seen enhanced for loops to get us through. So let me just show you that enhanced for loop example here on the screen, nice and big. And remember that the difference between these is that we're just reading the values in our array. In this enhanced for loop, we cannot change the values in our array, but we can read them. We've already seen this example. And we can see that here we can read the enhanced for loop as for each value in array. And one of the conventional namings here is that we can use plural nouns for your array because there's multiple in it, and then singular nouns for your element variables as you process through the enhanced for loop. So I might want to call my array items, and then in my enhanced for loop write it as for item in items. Now I do like to talk about two-dimensional arrays really quickly. We don't really do much with them. But, you can, like, for example, write a really rudimentary tic-tac-toe program with two-dimensional arrays. And I want you to be aware of what a two-dimensional array is. A two-dimensional array is essentially an array of arrays, which does kind of make things a little fuzzy, right? You might also call these matrices. Might be another word you hear used for these. Hash tables might be another name you hear for these. We use these as a way to kind of represent data values, and we can set them up in different ways. Two-dimensional arrays are more valuable in some other programming languages than they are in Java. One of the things that we often see in two-dimensional arrays in Java are when we're doing some kind of plotting or some kind of vector type math, because you can take and you can put an X value and a Y value. You can have a coordinate pair inside of one of these subarrays. But we essentially deal with a two-dimensional array in exactly the same way that we deal with a regular array, except we put another set of square brackets around it. And so in this instance, essentially we're creating a container of containers of containers. And so we can set up something like this where we have a two-dimensional array that we're calling A, and we're setting up a new integer array with 3 values and then 4 values. The first one being the number of containers in the main array, and the second one being the number of containers inside the containers. So if we were to visualize this, we would have one big container, which is our integer array. Three smaller containers inside of that. And then 4 subcontainers inside of each of those containers. So if we were to visualize this two-dimensional data structure for the data structure for this two-dimensional array, it would look something like this. All right, so let's head back over to our sample REPL here, and let's create ourselves a two-dimensional array. And we can see how we assign values to it and all that sort of stuff. So we'll create one both ways, right? We'll create an int, pair of square brackets, pair of square brackets. We'll call this one third set. And we can say that this is new int. We'll put 4 main subcontainers, and we'll do this idea of coordinate pairs. So we'll say that there are 2 data values in each of those subcontainers. So we have 4 sets of 2 numbers. We could also represent that like int get 4th set equals one comma 2 comma 2 comma 3 comma 5 comma 6, like that. Now when we iterate through each of these, we can see that it's a little bit different. Like if we try our for in enhanced for loop method, we can see what we get with that. So let's try that with one of our for int item in, and it would help if I put my parentheses here, for int item in third set. We can system dot out dot print line item. And let's just comment out this other stuff here just so we don't have to wait on it. We'll comment out from here to here. And run this and see what we end up with. We get an error. Because that's technically not an integer. That's an integer array that we're getting at that first level. So for int item of third set. Now we can get that, and we get these locations of these data sets. And if we say, if we put fourth set there, we should see something incredibly similar. Right, so in dealing with these two-dimensional arrays, what we often have to do is some nested loops. So for, we'll say set in fourth sets. And then for, inside of that, int item in set. So now this is saying for every set of arrays inside of this array, we're going to take every item inside of every array and we're going to print it out. And so that should give us our data values, which it does. And the same thing would work with third set, except everything would be zeros. Now, if we wanted to represent these as x and y coordinates, we can do that with our regular type for loops. So let's comment this one out now. But we're still going to have to nest them, right? So we'll say for int I equals 0. I is less than 3, because that's 0, 1, and 2. 3. I plus plus. And then inside of here, we'll do another nested for loop to get the interior values. So for, and since this is inside of this for loop, it knows what this I is, so we have to use a different iterating variable here. So this would be int j equals 0. J is less than 2. J plus plus. And so we can do things that way to print out every single item. Right, so to do what we've done here, in this method, we would say, let's see, we're using fourth set I j. So if we wanted to change the value in that, we could set that equal to a number. And if we wanted to print that out, we would add it to a system.out.println statement. And so when we run that, that'll look exact. That's essentially the equivalent code to what we wrote here. And if we want to get coordinate pairs, well, we can get rid of this interior part. We can say system.out.println x colon space, and concatenate that with the value that we have in fourth set in the I subarray in the 0th position in that I subarray. Y goes with the one in the first index location, and semicolon. So now that's going to give me everything as coordinate pairs. x1, y2, x2, y3, x5, y6. Multiple different ways to implement an array here. So before we wrap up, I'd like to show you all another example of something that we use arrays a lot for. And we are running really close to the end of time here. So one of the things that we often use arrays to do is to sort and do sorting, right? Like I can put multiple arrays or multiple numbers or even words inside of an array, and I can sort them. So we could do something like we were doing here, where we were having our user enter a number, and then we could print them sorted out from smallest to largest, for example. So what I'd like to do here as we wrap up is just a proof of concept for sorting. So to just kind of make matters a little quicker, I'm going to take and fork this one, and we'll change this to arrays sorting, and then we'll delete everything here that we don't need, which is basically everything. Don't want that. Don't need that for this proof of concept. We're just going to do this one really simple. And there are multiple ways to do this. Right, so what I'd like to do in this instance is create a string array. So we're going to, because we haven't seen a string array yet, so I'm going to create a string array. We'll give it the name R, like a pirate, right? And we'll set that equal to, and right now we're just creating a string. We need to add those square brackets, so we're creating a string array. And we'll go ahead and set up our array with certain values in it. So maybe tree, house, apple, and let's say baseball. In this example, we're going ahead and setting up our array with these values. In another example, you could do like we did in the last screen and just have the user enter them in. So what I want to do here is I want to create a variable so we can do some things dynamically. That's going to give us the length of the array dynamically. And we actually have a function built into Java that's going to do that for us. So in the previous example, we kind of knew how many were in there. So we could just use the number, but if we don't know how many array items are going to be in our array, if it's being set through a variable that our user enters or whatever, we can enter in our length method to get the length of our array dynamically. So we can set an int x equals the name of our array, R, dot length. And so that's going to get the length of the array as it is and pass it as an integer to this variable. So now what we can do is we can bubble sort, which is a type of algorithm. We can do some bubble sorting to take what we have here and put them into order. So that would be for int I equals 0, I is less than the value of x, I plus plus, And we're going to nest another for loop in this because we want this to keep going until it's finished. And we need a semicolon here, or else that's going to throw us for a wild loop. So for int j equals 0, j is less than x, j plus plus, we're going to create an, and so as we're doing this, what we want to do is we want to create an integer that's going to give us a value of that first letter, and we're going to see the difference in it. So int b equals rj, right? So that's going to take the string. So whatever item is there at that j index location, we're going to compare to rj plus 1. So it's going to give me the value at the current j location and the value of the j location at the next index location over. Now, because of that, because we're doing that, we actually want this x to be 1 less. So we need to subtract 1 from our r length, from the length of our array. And so this is going to give us a value of the comparison between one word and the other word. And as we've kind of talked about before, when our computers look at words, they look at them in terms of the ASCII values of the letters. So if the ASCII value is higher, then it comes later in the dictionary. And so what we're doing here is we're converting these words from their word value to their number value. And then we're bubble sorting numbers, basically. So we're not sorting words, technically, we're sorting numbers here. So I can say, well, if b is greater than 0, then that means that this word is bigger than this word, which means that our second word would come before the first word in the alphabet. So we'd want to switch those back and forth. In order to do that, we need to create ourselves a temporary container that can hold a value for just a moment. So that would be string temp equals rj. So that's going to hold our j value there for just a moment. That way we can take rj and set it equal to rj plus 1. And we could take that rj plus 1 and set it equal to our temp value. Because if we tried to set it to our j here, it would be different now. Right? That's why we use that temp variable. Because when we change it here, at this point, both rj and our index location j plus 1 are the same value. So if we tried to, that's why we need that temp. And so from here, we're essentially finished with this. We've sorted our words. And so what we can do is we can just use our enhanced for loop to print these out. So that would be for int, or this is a string, for string word in R. We're going to system.out.println word. And we're going to watch this sort our list for us. So let's run this. See the results. It should give us apple, baseball, house, tree. Instead of tree, house, apple, baseball, the way we have it here. So let's just see if it works. Let's see here. It's wanting to be, REPL's wanting to be slow again. Oh, here it goes. Here it goes. Apple, baseball, house, tree. We sorted our words. We did it. There's the proof. So we went through this list of words, this array of words, and we could have made this dynamically through user input. We don't have to. We could just do it this way. And we used our code. We converted these words to numbers. We looked to see if those numbers were bigger or smaller. And based on that, we did a bubble sort, which is this. Essentially, this part here with our nested arrays. And this part here is where we would see our bubble sort. Except in this instance, instead of b is greater than 0, we would say if rj is greater than rj plus 1, we can swap them. Right? So that's all that I have for you for today. I'll also put some other supplementary material into the module as well, along with this live stream for today. That's all that I have for you for today, though. If you have any questions, please let me know. I'm going to be hanging out in the chat for just a minute to see if anybody who's here with me live has any questions. But thank you for watching, and we'll see you next time.
Must be you and I. It's got me thinking about us more. It's these bright lights that put me in a daze, and I can't stop.